This is a short video segment that I'm preparing, and it's in a playlist called Transitioning to 3D Experience from the Abacus CAE. It is intended for people who are either new to 3D Experience or are Abacus users and are either migrating or planning to migrate at some point to the 3D Experience platform. Keep in mind that the native FEA solver in the 3D Experience is actually the Abacus program. The tutorial that I'm going to do today deals with how to introduce initial stresses / residual stresses in a very simple problem. What I have done is selected a particular video segment from YouTube where the YouTuber is actually doing this problem for in the Abacus CAE program, and I'm replicating his steps in order to show you the similarities and the differences between the two interfaces. Now, let me say a few words about this business of residual or initial stresses. There are stresses that get locked into the body after the source of that stress has been removed. Now, these stresses may be introduced intentionally. For example, when you're doing a shrink fit, you take a shaft that has a bigger diameter than the bearing, and maybe heat up the bearing so that it expands, and then put the shaft in it, and then let it cool down. So once that happens, the shaft is going to be under tensile outward stress, and the bearing is going to be under compressive stress, or the other way around, depending on how things are done. So these compressive and tensile stresses remain in the setup, but they are in equilibrium. That's why they're not causing too much of a problem. The problem is that when they're not taken into account, these stresses are not taken into account, and they're not equilibrating either, then that can cause a problem, and it may cause premature failure. Now, they can be introduced, these stresses, residual stresses, can be introduced by several different mechanisms, many mechanisms. Among them, there is a thermal cycle, just like I explained to you, for example, or phase transformations in object. Here's a situation where you can see that a part that has been uh, made using the additive manufacturing of metal, because of the presence of residual stress, has actually cracked by itself. You can see that. Okay. So the example that I'm going to be doing is taken out of this YouTuber's video tutorial, and he's taking a simple 100 millimeter by 100 millimeter uh, block that is 1,000 millimeter long. One end of it is clamped, and it's made out of steel. And what he does is that he takes the outer and the one on the left, the elements on the left and the elements on the right, all the way to the end, introduce, for example, a stress of 100 psi. These are just dummy numbers, uh, or MPa actually, and then take the middle section, introduces uh, a stress of positive, for example, 100 MPa. So the compressive and the tensile stresses, residual stresses, are actually in balance in that situation. So first I'm going to do this problem, and then I'm going to come back and take away one of these, for example, sides, and so that the two stresses are not initially at equilibrium, and therefore see how it's going to behave. So yeah, the inside is 100 MPa. The two outside set of elements are in compressive, minus 100 MPa, and obviously because of the geometry, these are in equilibrium, and it's going to be okay. But then I'm going to remove one of these and then see what happens. Uh, Now, in 3D experience, this initial stresses or residual stresses uh, is under the scenario tab. Okay, scenario application. So here's the tab called initial condition, and there is initial stresses. You can see that, and well, it says that define initial stresses on the body, of course. Now, when you click on it, this thing pops up, and notice that you have to go and select the support. The support can be the entire body or groups of elements or individual elements, cannot be nodes, and uh, either you can put it in or it can come from a previous step. This could be these stresses may be coming from a step that has already been done, and then you can use those values. Now, once again, keep in mind that these have to be applied to elements. Okay, and here is some online documentation for the from the help link of a 3D experience in case you want to consult it. Okay, so let's go ahead and actually make this thing. We're going to make a part, very simple part, 100 millimeter by 100 millimeter. So on that vertical plane, I will sketch a square like so. Let me give it dimensions. This is 100, and this one is also 100. Okay, exit, and then palette by 1,000 millimeters. 1,000 millimeters. Gonna look like this. This is made out of steel, so why don't we go ahead and apply material properties to it. So under tools, let's go ahead and create a material. We'll call it residual stress or initial stress example. It's November 14, 2023. Say okay. Okay, let me refresh this. Yeah, right here. Apply. Close that on that part, and then we're gonna go and input the values. That's very simple, just Young's modulus for steel and Poisson ratio. So it's going to be structural. You don't need the density, so Abacus multiphysics, mechanical, elasticity, elastic. Young's modulus is 200 GPa, okay, and Poisson ratio 0.3. Good. So now we're going to mesh this thing. Let's go to structural model creation. Empty FEM. I'm going to do a simple sweep mesh here. So on the mesh, we're going to do a sweep mesh right there. This object from this end to the other end. Global size 20 millimeters. Let's see how it looks like. I may want to increase the number of layers so that it kind of looks like that. It doesn't have to, but anyway, so let's check it out. Actually, let me make this thing because I want the equal number on both sides. So let me make this thing 10. Okay, so I'm going to change this thing to 12.5, so that I can have this proper number of elements. So 1, 2, and 1, 2, and then 4 in the middle. 1, 2, 3, 4 in the middle, so that it resembles this kind of a thing. The vertical number of distribution doesn't matter, and the depth doesn't matter either. That length doesn't matter. But I will change this thing to 20 so that it's closer to what I have in this situation. Okay, good. So we say okay. Now we're going to go and apply properties on that. So properties, solid properties on that part. Let me. I want to take the whole part. Maybe it's easier if I took it from the tree. Yeah, residual stresses, example, etc. So it's properties of steel. I'm pretty much done here. Now, before I go any further, I want to create group of elements, uh, two on the left, two on the right, all the way to the end. So here's what I'm going to do. First of all, let me look at this thing from the front. There we are. Okay. And then I'm going to do group. I will do the spatial group. So elements, drag a box around these two left column of element. Click on it. Notice that the box is created, but I want to go all the way to the end. So you have to drag this one of these yellow arrows to take this thing all the way to the end. Having a problem, just zoom in. Okay, further. Okay, so all the way to the end. So this is going to be called left. Okay, so these are, I'm going to call it left elements. Left element. And I don't want the nodes. Make sure you don't select the node. I want the elements and then say OK. So a group has been created here. You can see that. I'll do the same thing for the one on the right. So view from the front. One more time. Click on the spatial group. Make a box enclosing these. Click. And then go and increase the size of the box. There are other ways of doing this thing, but okay. And again, elements selected, and I'm going to call this thing right. Okay. And then finally, the stuff in the middle. So once again, view from the front, the third group, which is going to be the center one. So what is that? Spatial group. These guys. Okay. Maybe I may make this thing a little bit bigger to the left and drag this thing all the way to the end. It is already dragged in. And I'm going to call this thing center. Center. Say OK. Very good. So we have these three groups here. We are pretty much done. Now we're going to go to the structure model scenario, structural scenario creation, or you can go to mechanical scenario creation. Because I'm going to do a static problem. It doesn't matter. You can do it in either one of these. So let me go to structure uh, scenario creation. We are doing a static structural analysis of this mesh that we created. Good. So here's the situation. We're going to clamp the end. Okay. Now, before I do that, let me update because sometimes you won't be able to select these groups and you will have to update. So, but let me update this so that the groups, oh yeah, of course, we can't update it yet. So notice that no procedure has been defined. So let's do that first. So we go to procedure, the static. It's a very simple problem. So yeah, doesn't matter whether you do geometry, include geometry or not include it, it doesn't matter. So it is created, the step has been created. You can see that. Step has been created. And now we can update if needed because, yeah, good. Okay, so let me clamp one end. So I'm going to clamp the this end. So under boundary condition, clamp this face. Say okay. All right. And then apply initial stresses to these groups. Okay. All right. So let's say where is the initial stresses? So we go under initial conditions. Here is the initial stress. And I want to select this left group. If you cannot select these, make sure you update. I updated already, so that's okay. And the value in the x direction, sigma x in the x direction, let's check what we have here, compressive. So minus 100 MPa. Uh, I'm not sure if I can do simultaneously. Let me see now. Can I simultaneously do the right group? I think I can, but I'd rather do them separately, okay? So initial stress, this is the left group, so that's fine. I'm going to do it again. This one is on the right one, same value, minus 100 MPa, okay? And then another one for the center one, and this is going to be positive 100. So I have basically done this, okay? And that's pretty much it. So let's go ahead and save this thing. Notice there is no load here. There's no load. Uh, but there are initial stresses built in. However, these initial stresses are in equilibrium. So let's go ahead and run this thing. Simulate. So scenario check. This was an overkill to have the number of elements that I've selected, but that's okay. It's a simple problem. Okay, I think this is done. And finally run it. Simulate. By the way, these red thingies are the icon for initial stress. It's going to go quickly, I think, in pretty much 2 steps. 2 increments, really. That's what I mean. Extracting results. Very good. Okay, so let's close this. So this was the uh, before we kind of applied those initial stresses. If you go to the next one, next increment, next frame, that is what you're going to get. And this gives you the von Mises stress in the system. But I want to see actually uh, the components of stress. So let me double click on this left and go to first tab. And instead of von Mises, I want to look at the stress component 1, 1. Stress component 1, 1. That's sigma exact. So on the left and the right, it must be negative 100. In the middle, well, I mean, at the initial step, it should be minus 100. In the middle, it should be plus 100. So this is the uh, final result. There we are. Okay. So if you go to the first one, you can see that on the left and on the right, it is minus 100, and in the middle, it's plus 100. But after they deform, the object deforms because of the initial stresses, of course, things will change a little bit and looks like that. And if you actually, if you look at the plot of this deflection, it should be only axial deflection pretty much. So if you go to the displacement, okay, and if you increase the scale, because this is a unit scale, so let's go here to the middle tab, make this thing 100. See, it doesn't change, okay? It's just because it goes only in the axial direction. Okay, so this end, of course, they're fixed. You know that because in real life, I mean, if you have uh, clamped end here, things are going to look weird, but that's okay. So let me go ahead and put this thing back to where it was for now. So what I'm going to do is go and actually delete one of these initial stresses. So let's go back to scenario. Let's go back to scenario, and one of these initial stresses I'm going to delete. So for example, the one on the left or the one on the right. So if you go to the boundary conditions, actually initial condition. Let's say the left one is going, I'm going to delete. So there is more tensile stress than compressive stress now. So I'm going to either delete it, deactivate it. It's entirely up to you. Let me delete it and then run it again. So this will actually bend. If you look at the view from the top, I have already deleted the compressive stress on the left set of elements. Okay, there is compressive stress on the right side, and there is more tensile stress in the middle. That's fine. This is the clamped end. So there is no equilibrium between the initial stresses, and this is going to deflect. This is going to warp or deflect or move so that it tries to equilibrate that. In other words, tries to put more compressive stress in the middle, compressive, so that it actually can balance this guy. Remember, there was more stress, tensile stress in the middle section, okay? And what it does, it bends so that it introduces a compressive stress in the middle section so that it offsets that more tensile stress so that it becomes in equilibrium with that. So if you go ahead and run it now, if you go ahead and run it, this will bend to the left because that's the only way that it can introduce compression in the middle section and reduce therefore okay, so that's fine, and therefore reduce the effect. So if you look at the results, I think I already run that thing, so let's go ahead and look at the results. So on the procedure, no, on the results, this will bend to the left. This is the initial when you introduce the stress, and this is where it is. But I don't want the compression. I want the deflection, displacement. There we are. Okay. And if you look at the component, of course, you can see that the components is in the middle. It is 100. On the right side, on this side, okay, at the initial step, it's all minus 100. In the middle is 100, and of course there it's 0 because there's no initial stress. Anyway, good luck. So it's not that hard, but this is a very simple problem, of course. Good luck.